Dear students, welcome back to a new mathematics session. In the previous session, we have discussed the concepts of ellipse and we have solved problems from exercise 11.3. Hope it was clear for you all. In today's session, we shall discuss the concept of hyperbola and we shall solve problems from exercise 11.4. Let's move on to the topic. Let's begin with the definition of hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. It is a set of all points in a plane. The difference of whose distances, the property is that the differences of whose distances from two fixed points in the plane is a constant. When you take the distances of that particular point from the two fixed points and when you take the difference, it will be a constant. The collection of those points are called the hyperbola. Here, when we check, there are two fixed points here, f1 and f2, and we can see here, if you are taking a point p1 f2, this is the longer distance, p1 f2 minus p1 f1 means the distance of this point p1 from two fixed points f1 and f2, and you have to take the difference of these two distances, then it will be a constant and it will be same for all those points. Here p1 is a point, p1 f1 is a distance of that particular point p1 from f1, and p1 f2 is the distance of point p1 from f2. The bigger distance is p1 f2, so p1 f2 minus p1 f1 is a constant. And again, if you take p2, another point, that is p2 f2 minus p2 f1, that is also a constant, and that will be equal to the first one. And again, if you are taking another point p3, then p3 f1 minus p3 f2, that distances also will be same. So the property is that p1 f2 minus p1 f1 equal to p2 f2 minus p2 f1 equal to p3 f1 minus p3 f2. So this property, if it satisfies, then those collection of points we call it as hyperbola. Here two fixed points are called the foci of the hyperbola. Here we have considered two fixed points, one is f1 and f2. After fixing the points only, we are just finding out the distances. Here two fixed points f1 and f2, and these two fixed points are called the foci of the hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola. You can see here f1 and f2 are the foci, and midpoint connecting the line segment of this f1 f2, that means here will be coming the middle point, that is called the center of the hyperbola. Then the line through the foci is called the transverse axis. Here when we check, f1 and f2 are the foci, and the line f1 f2, this is a line passing through the foci, so that is called the transverse axis. And the line through the center and perpendicular to the transverse axis is called the conjugate axis. The line through the center means, as we know that the center is here, and the line through the center and which is perpendicular to the transverse axis. Transverse axis is f1 f2 and which is perpendicular means this way. So this is called the conjugate axis. Here two axes we have learned, transverse axis. Transverse axis means a line which is passing through the foci, and here another one is the conjugate axis. Conjugate axis means a line which is line segment which is passing through the center and perpendicular to the transverse axis, that is called the conjugate axis. The points at which the hyperbola intersects on the transverse axis is called the vertices of the hyperbola. The points at which the hyperbola intersects the transverse axis. See here, this is one hyperbola, this is another one. So these portions intersecting at the transverse axis at here. The points at which the hyperbola, here hyperbola is intersecting at this point, and on the right side it is at this point along with the transverse axis. So these 2 points are called the vertices of the hyperbola. So now we can just visualize all these things together here. So here focus, the two fixed points f1 and f2 we have called as foci, and the center of this f1 f2 is called, the midpoint of this f1 f2 is called the center, and a line segment which is passing through the foci, or a line which is passing through the foci, is called the transverse axis, and a line which is passing through the center and perpendicular to the transverse axis, that is called the conjugate axis, and the point at which the hyperbola intersects the transverse axis, that means this point and this point, these 2 points are called the vertices of the hyperbola. So these are the basic terms which we need to learn while we are studying hyperbola. Next we shall discuss the standard equation of hyperbola. So here there are 2 equations we need to learn. The equation of the hyperbola with foci on the x-axis is x square by a square minus y square by b square equal to 1. Here foci is on the x-axis. Foci is on the x-axis means the transverse axis is x-axis. That is x square by a square minus y square by b square is equal to 1. The shape of the hyperbola or the visualization of the hyperbola comes this way. Okay, so here you can see there the foci is on the x-axis, and the coordinates of foci we can just minus c comma 0 and here c comma 0. Okay, so the equation is x square by a square minus y square by b square equal to 1. The second case is the equation of the hyperbola with the foci on the y-axis. So y-axis means the equation start with y square by a square minus x square by b square equal to 1. How we have to write the equation, we have to be careful. So here the hyperbola's foci is on the x-axis. So x square by a square minus y square by b square is equal to 1. So here the equation of the hyperbola with the foci on the y-axis. Here the foci is on the y-axis. So the equation start with y square. So y square by a square minus x square by b square equal to 1. So the figure comes this way. Okay. Next we shall discuss a term, that is latus rectum. Latus rectum of hyperbola is a line segment perpendicular to the transverse axis through any of the foci and whose endpoints lies on the hyperbola. Here latus rectum of a hyperbola is a line segment perpendicular to the transverse axis. It should be perpendicular to the transverse axis, that is the first condition, and it should pass through any of the foci, that is the second condition. And if you consider that line segment whose endpoints must be lying on the hyperbola, then here latus rectum, length of the latus rectum formula is there, x square by a square minus y square by b square equal to 1. That is the equation of the hyperbola. Then the length of the latus rectum can be calculated by using the formula 2b square divided by a. So the length of the latus rectum of the hyperbola, x square by a square minus y square by b square equal to 1 is 2b square by a. Next is eccentricity of hyperbola. So the eccentricity of a hyperbola is the ratio of distances from the center of the hyperbola to one of the foci and to one of the vertices of the hyperbola. So it is a ratio of distances from the center to one of the foci and from the center to one of the vertex. So here E is equal to C by A, that is the eccentricity calculation formula. When we summarize all those terms so far we have learned, that is equation of the hyperbola, we have 2 equations learned, that is x square by a square minus y square by b square equal to 1. So here the transverse axis is x-axis, and when we check here y square by a square minus x square by b square equal to 1, then the axis of hyperbola or the transverse axis is y-axis. And relation between a, b and c, that we have to keep in mind, that is c square equal to a square plus b square. The coordinate of foci, that is plus or minus c comma 0, and the coordinate of vertex, that is plus or minus a comma 0, eccentricity c by a, latus rectum, length of latus rectum 2b square by a. This is the first case. When we consider the second case, the relation is same, c square equal to a square plus b square. Since the transverse axis is y-axis, the focus will be lying on the y-axis, that is 0 comma plus or minus c is the coordinate. Here also the points are on the y-axis, that is coordinate of the vertex, that is 0 comma plus or minus a. Eccentricity formula is same, c by a, and latus rectum is 2b square by a. So you have to go through this table very carefully and keep it in mind, because we need to use this one for solving the questions. Next we shall discuss the exercise problems. First question from exercise 11.4. Find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbola. X square by 16 minus y square by 9 is equal to 1. So here there is an equation given to us, x square by 16 minus y square by 9 is equal to 1. Label it as equation number 1. So for finding out all these eccentricity and foci, all these vertices, coordinates, if you want to find out, we need A, B and C. So first of all, we need to identify the axis of the parabola. Here the axis or the transverse axis. The axis of the parabola is x-axis because the equation starts with x square. So this is in the form x square by a square minus y square by b square is equal to 1. Then we can compare equation number 1 and 2. First of all, you need to identify the axis. Then equation you have to write x square by a square minus y square by b square equal to 1 with respect to the axis. Then we can compare. Instead of a square, here 16 is there. Then from here a we will be getting, that is equal to 4. Root of 16 is 4. Then instead of b square, here 9 is there. So b square is equal to 9. So b is equal to 3. Then we need a and b we have got. So we have to go for finding out c. So relation between a, b and c is c square is equal to a square plus b square. Then c square is equal to a square, that is 4 square is 16 plus b square, that is 3 square is 9. 16 plus 9 is 25. From here c we can calculate root to 25, that is equal to 5. So now we have got a, b and c. If you are having a, b and c, we can write all those required question answers. Coordinate of foci, that is the first one. Since here axis is x-axis, the point will lie on the x-axis, that is plus or minus c comma 0. Here we have a c5, that is plus or minus 5 comma 0. When we split and write, 5 comma 0 and minus 5 comma 0 are the coordinates. Next, coordinate of the vertices. Coordinate of the vertices is plus or minus a comma 0 because the major axis, the transverse axis is x-axis. Plus or minus a comma when 0, when a substitute in time, we will be getting plus or minus 4 comma 0. So the coordinates of the vertices are 4 comma 0 and minus 4 comma 0. We have to split. Okay. Then eccentricity we need. Eccentricity formula is equal to c by a. We have c is 5, a is 4. So eccentricity is 5 by 4. Length of the lattice rectum 2b square by a, that is 2 into b square, that is 3 square is 9. So 2 into 9 by 4. Then 2 into 9 by 4, we can cancel 2 and 4 in the numerator and denominator. These 2 and 4 cancelling time, here will be getting as 2. So 9 by 2. Next we shall discuss the second question. Find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbola. Y square by 9 minus x square by 27 is equal to 1. So here y square by 9 minus x square by 27 is equal to 1. That is a given equation. Label it as equation number 1. Then when we check here, the equation start with y square. So because of that, we can say the axis of the parabola is y axis. And the general form of equation of the hyperbola will be y square by a square minus x square by b square equal to 1. Label it as equation number 2. Now we can compare equation number 1 and 2. So here a square will be equal to 9. From there a we can calculate a is equal to 3. Then b square will be equal to 27. But here the problem is 27 is not a perfect square. So what we can do for calculating b, root to 27 we can take. Root to 27 we can write it as splitting by factorization, 3 into 3 into 3. Here this is this will be b. Okay, this is b. And when we check here, out of 2 3s, 1 3 will be coming out of the square root. That will be 3. Out of these 2 3s, 1 3 is out, then 1 3 is inside the square root. So 3 root 3, that is the value of b. Then c square is equal to a square plus b square, because we have got a and b. Now we can go with calculation of c. So c square equal to a square plus b square. C square equal to a square, that is 3 square is 9 plus b square is 27. 9 plus 27, that is 36. Then c is equal to root to 36, that is equal to 6. So a, b and c we have now. We can write the rest of the answers. Coordinates of the foci. Here the point or the axis of the hyperbola is y-axis. The foci will be on the y-axis. So 0 plus or minus c. C value we have 6, that is 0 plus or minus 6. The coordinate of foci here 0, 6 and 0, minus 6. Then coordinate of the vertices, that is 0 comma plus or minus a. Again this point also on the y axis because the axis is y axis. 0 plus or minus a. What is a? Here a is 3. So 0 plus or minus 3. When we split, 0 comma 3 and 0 comma minus 3 will be getting. Then eccentricity formula we know E equal to C by A. What is C? C is 6, A is 3. So 6 by 3 is 2. Simple question. Lattice rectum is 2b square by A. That is 2 into b square. So 3 root 3 the whole square. 3 root 3 the whole square. Otherwise you can write from here. B square is 27. So 2 into 27 divided by A. A is 3. So here 27 and 3 we can cancel. 27 and 3 when we cancel we will be getting 9. So 9 into 2. 9 into 2 is 18. So that is the length of the lattice rectum. Next we shall discuss the third question. Find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbola 9y square minus 4x square is equal to 36. And here let's write down the given equation 9y square minus 4x square equal to 36. First of all, when we consider the right hand side, for an equation of the hyperbola the right hand side is always 1. But here when we check the right hand side is 36. So first of all we have to remove this 36. What we have to do, we can just divide throughout by 36. So 9y square by 36 minus 4x square by 36 equal to 36 by 36. Here 36 when you divide you will be getting 1. Now we can cancel 9 and 36. When we cancel we will be having 4 here in the denominator. Then 4 and 36 when we cancel we will be having 9 in the denominator. Now the equation becomes y square by 4 minus x square by 9 equal to 1. Now the equation start with y square. So the axis of the hyperbola is y axis. So the general form will be y square by a square minus x square by b square is equal to 1. Now it is quite familiar, these two equations if you are having, we can find out all these terms. So here a square and 4 when we compare, these two will be equal. A square is equal to 4. A square 4 means A will be equal to 2. Next b square and 9 when we compare, b square will be equal to 9. Then b is equal to 3. Then a and b we have got. So c square is equal to a square plus b square. By using that formula we can calculate the value of c. That is equal to c a square. A square is 2 square. 2 square is 4 plus b square. B square is 3 square. That is equal to 9. So 4 plus 9. 4 plus 9 is 13. Then c when we calculate, root of 13 will be coming. Here it is calculated. So some of the steps, if you know how to write, then you can just simply use it, mental calculation, and write the answers. It's not an issue. Then coordinates of the foci. Here the axis of the hyperbola is y axis. The foci will be on the y axis. So 0 plus or minus c is the coordinate. That is 0 plus or minus c we have got root 13. So 0 plus or minus root 13. Then foci when we split and write 0 comma root 13 and 0 comma minus root 13. Next coordinate of the vertices. Coordinate of the vertices is 0 plus or minus a because the axis is y axis. So the vertex will be in the y axis. 0 plus or minus a is the coordinate. Then that is 0 plus or minus a, that is 2. 0 plus or minus 2. When we split and write 0 comma 2 and 0 comma minus 2. Next eccentricity is equal to c by a. C is root 13 and a is we have calculated as 2. So root 13 by 2. Next is lattice rectum, 2b square by a formula, that is 2b square by a is 2. So 2 into b square is 9 by 2. B square is here. Okay. 2 into 9 by 2. Then 2 cancel. Then we will be having answer as 9. So this is the lattice rectum. To the fourth question. Find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbola 16x square minus 9y square is equal to 576. So this is just similar to the previous question. Try it as homework. We shall discuss question number 5. Find the coordinates of the foci, the vertices, the eccentricity, the length of the lattice rectum of the hyperbola 5y square minus 9x square equal to 36. This is also quite familiar question only. Let's try to do it because calculation is a little different here. So let's write down the equation 5y square minus 9x square equal to 36. What we can do is the right side, first of all we will concentrate on the right hand side. We need to make it as 1. For that, divide throughout by 36. So 5y square by 36 minus 9x square by 36 equal to 36 by 36. Now, of course, the right hand side it is cleared here. It means it is 36 by 36, it is 1. But when we check on the left hand side, always the equation comes like this: y square by something, x square by something, like that only the equation comes. But here 5y square, here minus 9x square, like that it is there. Because we don't want this 5 here, we don't want this 9 here. What we can do is we can bring this 5 to the denominator's denominator. Okay, let's write y square divided by this 5 we are bringing to the denominator's denominator, that is 36 by 5, minus 9x square divided by 36. What we will write? X square by 36 by 9. 36 by 9 is 4, equal to 36 by 36 is 1. So let's I will show you how this one becomes changing, how this one is changing. Let's check. That is, you see here, this term will be considering. So when we simplify it, what we are doing is y square we will be taking, then division we will change to multiplication. This 36 by 5, when we multiply it, we will take the reciprocal, that is 5 divided by 36. This is what usually we just do when we do the calculation. Now you can check both. Now 5y square, you see this is 5y square divided by 36. Okay, so we are just doing the reverse process. If you want to bring this numerator 5, or if you want to remove this numerator 5, what we can do is just take and put it in the denominator's denominator. Because when we multiply, we are taking the reciprocal and multiplying, normally we will get the same thing. Okay, but here also the same thing, x square divided by 36 by 9. 36 by 9 is 4, equal to 1. So axis of the hyperbola is quite clear. Equation start with y square. So equation of the hyperbola is y axis. Then generalization is y square by a square minus x square by b square equal to 1. Then when we compare it, what we are getting, a square will be equal to 36 by 5. A square will be equal to 36 by 5. This one you can, the second equation I didn't mark here. So this one we can mark it as equation number 2. Then comparing equation number 1 and 2, a square we are getting as 36 by 5. Then b square we are comparing, we are getting as b square equal to 4. So b square equal to 4 means b is equal to 2. Square root of 4 is 2. Here a square is equal to 36 by 5. How do we calculate a? A is equal to root 36, that is 6 divided by root 5 as it is. So when we are taking square root of 36 by 5, square root of 36 we know, that is 6, root 5 as it is we can keep. So a, b we are having now. You can go with the c. C square is equal to a square plus b square. So c square equal to a is 6 by root 5 the whole square. Or else a square directly we can put, here the value is there 36 by 5, just to put it, plus b square value is there 4. So when we are taking LCM as 5, 36 plus 5 into 4, we have to multiply these two. 5 into 4 is 20 by 5, that is equal to 56 by 5. Then c is equal to root of 56 by 5, that is root 56. How do we split? Little bit of work we can do. So root 56, when we do root of 4, here we can take it as 4 into 14. 4 into 14 we can write. 4 into 14 is 56. And when we consider this 4, when we are taking out this 4 out of the square root, means 2 will become as 2 root 40 divided by root 5. Nothing can be done, just as it is we can keep. So c we have got as 2 root 14 by root 5. A, B and C all are having. So let's go for the answers. Coordinate of OK is 0 plus or minus C, because the axis is y axis. 0 plus or minus C. So 0 plus or minus 2 root 14 by 5. That is a C value, 2 root 14 by root 5. Then coordinate of vertices 0 plus or minus A. So here A we are having 6 by root 5. That is 0 plus or minus 6 by root 5. Then eccentricity is C by A. So what is C? C is calculated 2 root 14 by root 5 divided by A. A is 6 divided by root 5. When we calculate 2 root 14 by root 5 into reciprocal of the denominator, we have done here the same thing. 6 by root 5, when we take the reciprocal, root 5 by 6. Now what we can do, the cancellation cancellation is here root 5 we can cancel, then 2 and 6 we can cancel and write it 3 times. So we'll be getting as root 14 divided by 3, that is the eccentricity. Then the lattice rectum is 2b square by a, that is 2 into b square is 4 by a is 6 by root 5, that is 2 into 2 square is 4, this 2 square is 4, then this denominator 6 by root 5 we can multiply the reciprocal, that is root 5 by 6. Then here 2 and 6 we can cancel 3 times, so the answer will be 4 root 5 divided by 3. Of course the answer part explanation is not necessary because this is a simple calculations, you must do it without anybody's assistance. Move on to question number 6. Find the coordinates of the foci, the vertices, the eccentricity and the length of the lattice rectum of the hyperbola 5y square minus 9x square is equal to 36. So this question you will try it as homework. The 7th question. Find the coordinates of the foci and the vertices, the eccentricity, the length of the lattice rectum of the hyperbola 49y square minus 16x square equal to 784. Write down the equation. Then as we know the process now, right side we need to make it as 1, so divide throughout by that number 784. 49 by 784 into y square minus 16 by 784 into x square equal to 784 by 784. So 49 784 we can cancel, it will be 16 times, 16 784 will be getting 49 times equal to right side is 1. So cancellation is quite simple. Then here y square and x square also numerator there is coefficients 1 only. Of course the denominator is having 16, but here along with the y square there is no number, along with x square also no number, right side is 1. So it's in standard form. Since the equation start with y square, the axis of the parabola is y axis. Then the general form will be y square by a square minus x square by b square equal to 1. So equation number 1 and 2 we are having the same process like the previous questions. Just to compare it, and write down a and b values. So a square is here 4 square. A square equal to 4 square means a will be 4. Next is b square is equal to 7 square, that means b is equal to 7. So now a and b we are having. Now c we have to calculate by using the formula c square equal to a square plus b square. If a, b and c are there means the rest of the calculations you can do it as the previous question. You will try it as homework. On to the 8th question. Find the equation of the hyperbola satisfying the given conditions. Vertices plus or minus 2, 0. Foci plus or minus 3, 0. So just somewhat different question when we compare with the previous questions. Here vertices plus or minus 2, 0 and foci plus or minus 3, 0. When we observe these two coordinates, quite clear that these two are on the x-axis. So the axis of the parabola will be x-axis. You see here y value is 0. Y value 0 means the point will lie on the x-axis. Vertex and foci will lie on the transverse axis. So the transverse axis or the axis of the hyperbola will be x-axis. So given vertices plus or minus 2, 0. The vertices are on the x-axis. The coordinate of the vertices will be plus or minus a, 0. So this is what we have to identify the axis, transverse axis. Then we can write the general form. Coordinate of the vertex formula is plus or minus a, 0. So here when we compare plus or minus a and here coordinates plus or minus 2. So a will be equal to 2. A is equal to 2. Then coordinates of foci is plus or minus 3, 0. So the general form of foci is plus or minus c, 0. Okay. So plus or minus c, 0 and plus or minus 3, 0. When we compare these two, we will be getting c is equal to 3. So we have a and we have c. Now we can calculate b because we want b for writing the equation of the hyperbola. So c square is equal to a square plus b square. Then when we substitute c is 3 square equal to a is 2 square plus b square. Then 3 square is 9 equal to 2 square is 4 plus b square. So b square equal to this, bring to the left side, 9 minus 4. 9 minus 4 is 5. So b square equal to 5. Now we are having both a and b, we can go for writing the equation of the hyperbola. Equation of the hyperbola we have discussed before. The axis, that is very important, the axis is x-axis. So the equation start with x square by a square minus y square by b square equal to 1. So x square by a square is 2 square 4 minus y square by b square is 5. So x square by 2 square minus y square by 5 is equal to 1. That will be x square by 2 square. 2 square is 4. X square by 4 minus y square by 5 is equal to 1. So this is the required equation. Quite simple question. Even this much steps are not necessary. Directly you can compare. Vertex you can write plus or minus 2 comma 0. That will be equal to plus or minus a comma 0. Then we can compare the coefficients. Coordinates. Likewise, for key also plus or minus 3 comma 0, you can just directly equate with plus or minus c comma 0, and we can write down the equation. Next, we shall discuss the ninth question. Find the equation of the hyperbola satisfying the given conditions. Vertices 0 comma plus or minus 5, foci 0 comma plus or minus 8. So here vertex and foci are given. You can see both are on the y-axis values. You see here x values are 0. That means these 2 points lie on the y-axis. So the axis of the hyperbola will be y-axis. Let it be there in your mind. So vertices are on the y-axis, means 0 comma plus or minus 5 is the coordinate. That will we can equate with the general form, that is 0 comma plus or minus a, that is the coordinate of vertex. Then when we compare these two, a will be equal to 5. Then a square we need for writing the equation, so a square equal to 25. Next, foci is given to us 0 comma plus or minus 8, but the general form is 0 comma plus or minus c. When we compare these two, c will be equal to 8, so c is equal to 8 will be coming. Here also c is there, but b is not there, so we need to go for finding b. How do we calculate b? By using the formula c square equal to a square plus b square. That is c is 8 square equal to a square, that is 5 square plus b square. Then b square equal to 8 square is 64 minus 25. So 64 minus 25 is 39. So b square is equal to 39. We have everything. Now we can write. Before that, let's recall once again the axis. Here the axis is y-axis. So y-axis means equation start with y square. So y square by a square minus x square by b square equal to 1. Then y square by a square, that is 25, b square is 39. So y square by 25 minus x square by 39 is equal to 1. So this is the required equation. Move on to the 10th question. Find the equation of the hyperbola satisfying the given conditions. Vertices 0 comma plus or minus 3, foci 0 comma plus or minus 5. Similar to the previous question only. Both the points are on the y-axis because x value is 0. So the axis of the hyperbola is y-axis. Vertex is given 0 plus or minus 3. That will be equal to, or that we can compare with the general form 0 plus or minus a, because this is the general form of vertex. So 0 plus or minus a. When we compare, a will be equal to 3. Then foci 0 plus or minus 5. That will be comparing with the 0 plus or minus c. When we compare these two, 5 will be equal to c. Like before, a and c are there, b is not there. We will go for calculation. C square equal to a square plus b square. C is 5. So 5 square equal to a is 3 square plus b square. That is 25 is equal to 9 plus b square. Then from here b square we can calculate this, bring to the left side. That is b square equal to 25 minus 9 is 16. So required equation. We are having both a and b square. Of course, we can write the equation. Equation of the hyperbola writing time, but the axis we have to check. Axis is y-axis. We have discussed before. So y-axis means equation start with y. So y square by a square minus x square by b square is equal to 1. Substitute y square by a is 3. Y square by 3 square minus x square by b square is 16 equal to 1. So this is the required equation. Dear students, today we have learned the basic concept of hyperbola and we have solved first 10 questions from exercise 11.4. Go through all those 4 conical section shapes like circle, parabola, ellipse and hyperbola, and compare the formulas and learn properly. And while learning, if you are having any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.